What if everything you've been told about wormholes is completely wrong? For nearly 90 years, scientists and science fiction writers have imagined wormholes as cosmic tunnels connecting distant corners of the universe. However, groundbreaking research published in 2025 revealed a shocking truth. Wormholes have never been about space. They are about something much more mysterious, time itself. And this discovery could rewrite our entire understanding of reality. Let's take a closer look. The story begins in 1935, when Albert Einstein and his colleague Nathan Rosen published a paper that would preoccupy the physics world for decades. They weren't trying to build a cosmic highway or create shortcuts in space. They were grappling with a much more fundamental problem. How do particles behave when gravity becomes extreme? They were searching for the answer to this question. Their mathematical solutions, later called the Einstein-Rosen Bridge, would be misunderstood for generations. Today, we finally reveal what they actually discovered. Ready to learn something different? When Einstein and Rosen introduced the bridge concept, they were tackling one of the most challenging problems in theoretical physics. How can you consistently describe particles when space-time itself is violently warped? Their answer was elegant but strange. They proposed a mathematical structure connecting two perfectly symmetrical space-time layers. This was not science fiction. It was pure mathematics designed to prevent the breakdown of physical equations under extreme gravity. The bridge preserved quantum consistency. It had nothing to do with travel, tunnels, or transportation. It was a tool to maintain mathematical consistency, not a blueprint for cosmic shortcuts. But then something unexpected happened. Decades later, physicists began to reinterpret this mathematical structure as something physical, namely a passable tunnel in space. The term wormhole emerged. Popular culture embraced the concept. Science fiction became wildly interested in the concept. And slowly, the original purpose of Einstein and Rosen's work became buried under layers of speculation and imagination. Why did the wormhole idea fail? The problem is this: even in Einstein's own general relativity theory, these so-called space tunnels don't work. Detailed mathematical analysis shows that they collapse catastrophically faster than light itself could pass through them. Imagine trying to pass through a door that closes in a trillionth of a nanosecond. These structures are that unstable. To keep a wormhole open, you need a substance with a negative energy density that repels gravity instead of attracting it, what physicists call exotic matter. Despite decades of research, no such substance has ever been found in nature. The commonly imagined concept of a wormhole is trapped in a world of mathematical possibilities without a path to physical reality. However, recent research published in the January 2025 issue of Classical and Quantum Gravity reveals that we have been asking the wrong question all along. The Einstein-Rosen Bridge was not misunderstood because we lack exotic matter. It was misunderstood because we were looking in the wrong dimension. The new interpretation is radical. The Einstein-Rosen Bridge is not a connection in space but a connection in time. More specifically, it is a quantum connection between two opposite time arrows. Here's how it works. At the deepest level of physics, the laws of nature make no distinction between past and future. If you reverse time in the fundamental equations of quantum mechanics or general relativity, the equations remain completely valid. This time symmetry is embedded in reality itself. Yet our everyday experiences are clearly unidirectional. We remember the past, not the future. Causes precede effects. Coffee cools. It does not spontaneously heat up. These apparent arrows of time arise from thermodynamics and entropy. They are a macroscopic feature of large systems, not a microscopic law of physics. Researchers argue that for a complete quantum description of reality, especially in extreme environments, we need both directions of time. One component of the system evolves forward in time. A complementary component evolves backward from a mirror image state. Together, they form a complete physical system. The Einstein-Rosen Bridge emerges as the mathematical structure connecting these two temporal components. This is not optional, it is necessary for quantum coherence and reversibility. In ordinary situations, we ignore the backward time component because entropy dominates. However, near black holes, in the early universe, or under other extreme conditions, both directions become significant. What do you think about this? This reinterpretation solves the black hole information paradox, one of the most famous puzzles in physics. For decades, scientists have grappled with a troubling question. Do black holes destroy information? According to quantum mechanics, information cannot be destroyed. It must be conserved. Yet black holes seem to violate this sacred principle. If we assume a one-way flow of time passing through the event horizon of a black hole, information appears to be lost forever. However, with the new two-way time framework, the paradox disappears. Information is not lost, it simply flows in the opposite direction of time. From our perspective, looking at the black hole from the outside, information appears to be lost. With a complete quantum perspective that includes both time arrows, information is perfectly preserved. It is a matter of perspective, not a matter of annihilation. In November 2025, researchers at Princeton and in Argentina published an additional study supporting this idea in the journal Physical Review Letters. They mapped the internal structure of entangled black holes and discovered the Einstein-Rosen wormhole, a long, winding structure connecting quantum entangled black holes. This finding strengthens the deep connection between quantum entanglement and the geometry of spacetime. Perhaps the most mind-boggling implication concerns the origin of our universe. If this interpretation is correct, the Big Bang may not be the absolute beginning of time. Instead, it could be a quantum transition, a jump point where one cosmic phase reverses time and transitions into another. Imagine a universe approaching maximum density, collapsing. Instead of collapsing into a singularity, time reverses direction at the boundary, and the universe begins to expand again. Our universe may not be the first chapter of existence, but the continuation of a previous cosmic phase. In this picture, black holes are not spatial tunnels. They are temporal boundaries, transition regions where the direction of time changes. They do not connect different places, they connect different temporal flows. The wormhole metaphor is not only wrong, it points to the wrong dimension. This framework also offers testable predictions. If time-symmetric quantum structures exist, they may leave observable traces. Subtle anomalies in the cosmic microwave background, unexpected patterns in large-scale structure formation, or unusual relic particles could provide evidence. Some speculative models even suggest that certain forms of dark matter could be relics from the pre-Big Bang universe, matter that crossed the time boundary. This research is connected to broader efforts in the field of quantum gravity, where time itself becomes problematic. Many advanced models suggest that time is not a fundamental concept, but rather a property emerging from deeper quantum structures. In May 2025, researchers at Aalto University published a new quantum gravity theory that brings us one step closer to unifying gravity with quantum mechanics using a gauge symmetry similar to the Standard Model. The Einstein-Rosen Bridge, reinterpreted as a temporal quantum structure, fits naturally into these frameworks. This bridge is not a geometric structure for travel, but rather a mathematical expression of how quantum evolution works under gravity. What makes this significant is not exotic technologies or science fiction scenarios, but the potential to consistently unify quantum mechanics, gravity, and time without violating known physical laws. The fantasy of cosmic tunnels has been replaced by something deeper, a universe where time has a hidden structure beyond our everyday perception. As a result, for nearly a century, the Einstein-Rosen Bridge has been misinterpreted as a wormhole, a tunnel through space that captured our imagination but contradicted physical reality. Now we are discovering its true nature, not a shortcut through the cosmos, but a mirror within time itself. What is needed to define reality under extreme conditions is the quantum connection between opposite time flows. Future research will test whether these time-symmetric structures leave observable traces in astrophysics and cosmology. The theory will be valid or invalid depending on its predictive power and empirical consistency. But one thing is already clear: wormholes as we imagine them do not exist. Instead, what they reveal is something much more fundamental, a hidden symmetry of time that could reshape our understanding of existence at its deepest level. The universe is stranger than we imagined, and this strangeness stems from aspects we are only beginning to understand.